He kōna ipurangi tēnei nā te reo irirangi o Aotearoa.
Ngā mihi nui and welcome to Elemental, a podcast from RNZ exploring all the chemical elements to mark 150 years of the periodic table. I'm Alison Ballance.
And I'm Allan Blackman from the Auckland University of Technology. We are up to episode 39, and that makes it Iridium, which is most famously known for geologically marking the end of the dinosaurs.
Now, before we get to how it done it, let's do the who done it. Can you please tell me about Iridium?
Okay, so the vital statistics as per usual. Elemental symbol IR, atomic number 77. And that puts it in the transition metals, and in fact in group 9 of the transition metals.
Now, I don't think the name Iridium means dinosaur slayer, so what does it mean?
It comes from the Greek Iris, who apparently was the messenger of the gods and the Greek goddess of the rainbow. And that's the telling factor in this, because the salts of iridium have many very different colours. So it was originally isolated in 1803, along with one of its transition metal neighbours, osmium, from an impure sample of platinum, as these elemental discoveries were so often done, by a man called Smithson Tennant. And one of its claims to fame is that it is the second most dense element on the periodic table. So if you think lead is pretty dense, which it is, then this stuff is twice as dense as lead. And it is the most corrosion-resistant metal. And remember when we talked about gold, we said that gold pretty much only dissolves in one thing, and that was a thing called aqua regia. Aqua regia doesn't even touch iridium, and that is one of the ways in which it was first found, because you could dissolve everything away except the iridium. As a result of its chemical non-reactivity, it was often used in fountain pen nib tips, for those of you who can remember what fountain pens are. So iridium-osmium alloys were often used, and the first major use of iridium was in 1834 in fountain pen nibs mounted on gold. So for a while, the famous Parker 51 fountain pen was fitted with a nib tipped by a ruthenium and iridium alloy containing 3.8% iridium. So the tip material in modern fountain pens, again if there are such things, is still conventionally called iridium, even though there is seldom any iridium in it.
I agree with you. I suspect an awful lot of people these days certainly don't use fountain pens, and a growing number probably don't even know what a fountain pen is.
Ah, that's a shame. I remember those days at primary school. When you were good enough with a pencil, you were allowed to go on to a fountain pen. But,
and got ink everywhere from memory.
Oh, yes, indeed. Blotting paper. That's what blotting paper was for. But people don't use blotting paper anymore. Anyway, I'm digressing. There are other uses for iridium that rely on it having a high melting point and being very hard. Two of these are in cars, so spark plug tips, you can well imagine that you wouldn't want anything corroding there. And also catalytic converters that are in your exhaust and help convert all these nasty nitrogen oxides to harmless nitrogen and oxygen.
How common is it?
Yeah, no, this one's pretty rare. In fact, it's around about 40 or so times rarer than gold. And so, as you might expect, that does make it slightly more expensive than gold, where gold was about 60,000 New Zealand dollars a kilo. Currently, iridium's around about 70,000 New Zealand dollars a kilo.
Why is it so rare?
Good question. The current theory with this is that iridium is what we call a siderophile, or an iron-loving element. And so it goes where iron goes. And as we will find out when we do the episode on iron sank into essentially the Earth's core, and it took a lot of the iridium with it when it did that. And as a result of that, iridium is produced by some volcanoes. On the Earth's crust, it's not particularly common, and what we find is that iridium is much more common in asteroids. They don't have the iron cores that the Earth has, and so the iridium is evenly distributed. This is one of the big plans of people who want to make lots of money. They reckon that one day you'll be able to mine iridium from the asteroids. And that's not its only geological connection. Its main claim to fame, the reason why people have heard of iridium, is indeed also geological.
That's right. The extinction of the dinosaurs and ye olde KT boundary, although that's the name I grew up with. course, they've changed it now, so it's now the KPG boundary, which isn't so easy to say, but is more accurate.
What you find if you start digging is that you hit a thin layer of sediment which contains high levels of iridium, and that's present in rocks all around the world that were deposited between the Cretaceous and the Paleogene geological periods. And in other words, that's pretty much exactly the time when the dinosaurs went extinct. So there's various theories as to why this iridium is there, but the best, or I guess the most accepted, involves the fact that the iridium present in this sediment is in much, much higher abundance than elsewhere on Earth. And so therefore, as we mentioned before, this would be consistent with that iridium having come from a meteor impact. And this led to a thing called the Alvarez hypothesis. And this was the idea that an asteroid which was around about 10 kilometres across, which really on the grand scheme of it doesn't seem that big, would have contained enough iridium to explain the amount on the KPG boundary. And Luis Alvarez came up with this idea before an impact crater was actually found.
And then they found one.
Oh, yes, indeed. Basically, it's been proven since, because this whole theory ties in with the fact that a meteor landed in the Yucatan Peninsula in Mexico and formed what is called the Chicxulub crater. And this is estimated at around about 10 kilometres across. And what is thought to have happened is that the impact of this 10-kilometre meteor led to a darkening of the sky, and that eventually ended up killing the dinosaurs. And so no dinosaur fossils have been found above this boundary, and that pretty much provides further evidence of the correctness of the Alvarez hypothesis.
Of course, to be a pedantic biologist, I should say it didn't kill all the dinosaurs, just the non-avian ones. We still have birds and they are dinosaurs. But it's pretty cool that one chemical element defined such a precise end to a geological era.
Absolutely, yeah. Yep.
Now, time for today's random elemental fact, please.
Okay, because it doesn't corrode, iridium was used in the standard metre bar, and this was a bar of length 1 metre, and that was used from 1889 until 1960, and it was made of 90% platinum and 10% iridium, and that defined the metre that was used all around the world. And not only length, but it was also used to define mass. So the same 90%, 10% alloy was used to define the mass of a kilogram. And until just a month ago, it was still the international standard of mass. And that all changed on the 20th of May. And the reason it was used was because it is corrosion resistant. So there you go, that's iridium.
Well, just like the Elemental podcast, which we hope will weather the test of time, you can see if the previous episodes are in fact weathering well by checking out the archive, rnz.co.nz/chemistry. We are also available on your favourite podcast app, whatever that may be. We're back next time with iron, so we'll be finding out more about the core of the Earth then.
Absolutely will.
But until then, it's goodbye from me, Alison Balance.
And goodbye from me, Allan Blackman. See ya.